Dear participants, welcome to Port International Congress on Human-Computer Interaction, Optimization, and Robotic Applications. We are in station 9.4 now, and we have 11 papers that will be presented in this session. All speakers will have 10 minutes to present their studies, and we will start with the paper number of 330. The title of the paper is Comparative Analysis between the Traditional and Nearest Centroid Methods in the K-Nearest Neighbor Algorithm. The authors are Svetlana Mladonova and Irina Volova. Is the author here?
Yes.
Okay, you can share your screen and start your presentation.
Okay, let me just do this. Do you see my screen?
Yes, we can see your screen and you can start.
Okay. Hello, dear guests. My name is Svetlana Mladonova, and I'm going to present our paper, Comparative Analysis between the Traditional and Nearest Centroid Methods in the K-Nearest Neighbor Algorithm. The nearest neighbor algorithm was presented in 1951 by Fix and Horst and is based on the idea of calculating the distance between an unknown object and its nearest neighbor, one nearest neighbor, from a training set. This method was further developed into K nearest neighbor, meaning that not only one neighbor is taken into consideration, but a number of neighbors. Due to its simplicity and easy implementation, the method of nearest neighbors, as well as some of its modification, in particular the nearest centroid neighborhood, is subject to many different studies. The main purpose of this study is to make a comparison and statistically test which of the two options, the traditional or the nearest centroid, is better in classifying data from small and medium-sized businesses and datasets. The datasets used in this experimental study were selected to correspond to the data that a small business would have, such as small learning sets of data, different types of data, data with outliers, and balanced data. The structure of the data that is used is shown in this table, 18 different sets with in ascending order. All experimental studies were performed with M-fold cross-validation, where M is equals 10, as this is a number of accepted number in this current research and by many other authors. The results of each iteration are stored and the average value of the model accuracy is obtained. The following figures show the selected neighborhood for two of the datasets, actually for one of the datasets, the hepatitis dataset, with both of the methods, the traditional method and the nearest centroid neighborhood, and the K parameter is equals 4 for neighbors. The results in the hypothesis training are shown in the table here. And the hypothesis test was performed with students' t-test, which considers an objective way, which is considered to be an objective way to test models in machine learning when the study is performed between two models in n iterations, where n is less or equal 30. In our case, is equals 10, so it's appropriate for our tests. The table that shows the results from the hypothesis test show that in some cases, the nearest centroid neighborhood performs better than the traditional method. In only two of the tests, the dataset with the stars and the datasets with the ionosphere. But it should be noted that these tests are performed in a specific method. All of the features are used. The number of the K parameter is the same for every dataset, which is proven to be not that efficient, meaning that the K parameter should be different with different data sets with different conditions. In conclusion, the experimental studies have shown that there are statistically significant improvements in the effectiveness of nearest centroid neighborhood classification in two of the datasets, of the training datasets. These results are not satisfactory, but it should be noted that this experimental study considers the traditional method of the nearest neighborhood without any further modifications, and the K parameter equals five neighbors. The combination of another size of the neighborhood and a modification of the algorithm, for example, by weighting the neighbors, will lead to other results where there could be significantly statistically improvements and difference between the two methods. Thank you for your attention, and I'm happy to answer to any questions if you have.
Thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, I guess there are no questions. We can go on with the next paper. The paper number is 357. The title of the paper is Research on the Ability to Detect Fake News in Users of Social Networks. I guess, again, you are going to present?
Yes.
Okay, you can start your second paper.
Sir?
Sorry?
Excuse me, but can I begin now because I have to go to Baghdad, to travel to Baghdad?
Sorry, I can't hear you. I didn't understand.
Can I begin now because I have to go to Baghdad now?
What is your paper number?
Wait. 254.
254. But we should ask her, do you let him to present?
Yes, it's okay with me.
If it's okay with you, okay.
Yes.
Thank you very much. Thank you very much.
Okay, now we are going with the paper number 254, data mining and RBF neural networks to analyze data from COVID-19 patients and predict new cases based on symptoms. Faizes Al-Rufai will present the paper.
Yes, thank you very much.
You're welcome. You can start.
Hello, everybody. I am Faiz Al-Rufai from Iraq. I have master's degree in computer science, Middle Technical University. We will begin with this paper, data mining and RBF neural network to analyze data from COVID-19 patients and predict new cases based on symptoms. So we'll begin now. In the end of 19, we have a new disease. It is COVID-19. So we have a lot of people with this virus, and all people who can go to doctor. The doctor will collect, store, and analyze a set of information about patient to be used in diagnosis. This is based on prior medical facts and procedure and experience. So with computer science, we can get very good results to detect or predict a new cases for this virus. So we have successfully used computer science in a number of medical fields, including based system and knowledge-based system, and both systems have problem in medical diagnostics. As a result, neural network is the best method to detect and predict new cases for many diseases. So in our current study, we collect data from patients who had COVID-19 and were examined in Iraqi hospital and health center, and we mined that data to obtain knowledge and data on final cases. After that, we developed algorithm that uses radial basis function neural network technique to build a system. It predicts COVID-19 by entering a set of inputs that reflect the virus, then introducing the disease output in the training phase. So okay, excuse me. COVID-19 is begin with the Chinese city of Wuhan at end of 19. A lot of people have this virus. Is known as corona because it's like crown like this. Okay, is the same SARS but with another shape. So in our work, we based on radial basis function neural network technique. It type of neural network. We begin work with this technique to resolve a problem as a human. Human is think to solve any problem. So with work with computer, same that. Neural network, it simulates problem like artificial neurons So artificial neurons are a set of linked nodes in a artificial neural network that freely represents neurons in the biological brain. A signal can be sent to other by any link, such as synapses in biological brain. Artificial neurons receive a signal, analyze it, and then send a signal to the neuron with which is linked. The initial step of radial basis function neural network is training, and the second end is testing. In the first step, the neurons are taught their input and output, as well as how to interact with a set of weights to obtain those outputs, and then the outputs are matched. In the test, we will give the system only input without output to get output. We have two figures to show testing and training neural network. This first one is for training neural network. You can see the input will come to RBF neural network with weights. Okay. So we will get output. This output will matching with target output. We have target output from health center for any patient will matching with the output. If it's okay, so this output. If not, we will go back to algorithm. This for training neural network, and we have for testing neural network. You can see this without matching. Just we will get input and go to algorithm, and we'll have output from this algorithm. There are three layers to radial basis function neural network. The input layer is made up of series of nodes, each of which presents a system output. The second layer is a hidden layer, contain neural network function as well activation function. After processing the hidden layer, we'll get third layer is output layer. We can see this function, this figure for three layer: input, hidden, and output layer. For every neural network, maybe must can use function for improve or enhance output. So in this paper, we use Gaussian function to enhance output. Gaussian function it have viewer parameter like this function, Gaussian function. We have a function for exponential x minus b to power 2 to c to power 2. For c, okay, and we have another function for RBF, radial basis function neural network, is summation for weighting and parameter as inputs plus faces.
Mr.
all-
Al-Rufai, your 10 minutes duration is over. We request you to summarize your paper.
Okay. In Iraq, we don't have any technical in our hospital, so all information is on paper. So we faces difficult to collect data from hospital. So we will use data mining to extract knowledge from this information. Okay, we talk about RBF neural network stage. Training and testing phases. So this for training, we will begin with start and get data set and generate random weight and function for RBF and function for Gaussian. Then we'll get output and matching with target and end. This is our result for our program. We have 12 sample from our patient. So we will get this result. Number one is for positive, 0 for negative, and 2 is very effect for this. Okay, and COVID, we have 2 line, COVID and NN COVID. COVID is the result from health center, and NN COVID is for from our system. This for training state or training phase. This for testing phase. Okay. When development and implementation COVID-19 cases prediction program using the RBF neural network, we discover a number of drawbacks. The most, which is the need to collect large amount of data for the system, is very difficult for in our Iraq. Okay, the system is strongly reliant on the data entered into. Okay, the number the number of neuron in the hidden layer is important in the accuracy and the strength of the result, because increase in the number of neurons in the hidden layer leads to a rise in weight, which has a beneficial impact on the system output. Thank you very much.
Thank you very much for your presentation. Dear participants, are there any questions about this paper? Okay, there are no questions. We will go on with the next paper, 357. Ms. Mladenova, you can share your screen and present your second paper.
Okay, but I cannot share my screen if there's... Yes.
I will now
Mr.
finish.
Arufai, please.
Yes.
Okay, thank you.
Just a second. Yes, you are seeing my screen?
Yes, we can see your screen.
Okay. This paper is research on the ability to detect fake news in users of social networks. The ability distinguish truth from fake is a knowledge that people acquire through experience and age. And from a young age, children are taught to spot lies and deception. And for decades, people have been able to recognize lies in general. In past decades, the only means of reaching the population are television, newspapers, and radio. Through them, people are learning the news in any form and are able to form their opinions and thoughts. These type of sources are the main source of knowledge about the surrounding world. These days, we are witnesses to the global phenomena of social journalism, which gives the ability of everyone having some kind of social account and decent phone with a camera to become essentially a journalist. This has become the new normal for people to participate in the process of news creating by sharing first account information, capturing videos, photos of various important events and sharing them on platforms such as Facebook, Twitter, YouTube. And having this ability to post whatever and whenever, everyone can become a source of both trustworthy and fake news. That's why a survey was conducted by us among 137 participants of different ages and backgrounds, including high school students, university students, graduates, working in a variety of professions such as engineers, accountants, teachers, librarians, designers, so on and so on. On this table, you can see the distribution, age distributions in our participants. Due to the number of participants in the ages of 40, 50, and 60s, these groups are not taken into consideration in the general conclusions. And an additional survey, it's a good idea to be made an additional survey for these age groups because they are interesting and actually are big contributors to the problem of fake news. The questions in this study, there were 32 questions, 4 for demographic purposes, age, and so on, 16 general questions, and 12 practical questions or tasks. Some of the general questions include: what would you watch when you come home from work? What is your main source of news? Have you come across fake news? Do you check the source of the news? And so on. After the general questions, the 16 general questions, the participants are shown 6 screenshots from various Facebook posts. Some of the screenshots are shown here on this slide, and under every screenshot, the question, do you think that this is a fake news and or a clickbait, is displayed, and the user has to answer this question based on the screenshot that is shown to them. After that, after these 6 questions, some definitions about the terms fake news and clickbait are shown, and the participants are prompted to read these definitions, then to answer the question if they have read these 2 definitions. And after that, the last section contains again the remaining 6 screenshots. These follow-up sessions aims to test the ability of fake news recognition in the respondents after some additional clarification of the terms fake news and clickbait is given. Results in these 2 figures shows the answer to the question, what would you watch when you come home from work? The question specifies the situation when the person has come home from work, and this part of the day is usually when a person is tired from the workday and is more susceptible to external influences. It's noticeable that the age group of teens and 30s are the ones that are actively watching some form of television. Comedies and criminal movies and series are one of the most preferred forms of after-work relaxation, while the daily news is not that preferred. The right part of the figure shows that the respondents having a higher education degree prefer comedies, criminal movies, and series, as well as scientific documentaries and watching the daily news. The answers to the questions, do you know what a fake news is, and do you know what a clickbait is, are shown in this diagram. 93.8% of the respondents claim that they know what a fake news, and 79% of them clickbait. It is no surprise that the percentage of people who knows the term fake news is bigger, as there is quite a lot of media coverage on it. News about fake news, informational campaigns, and so on. There is noticeable less widespread information about the clickbait, but nevertheless, the percentage of people who have at least heard the term and have basic knowledge what the term is quite satisfactory. A distinctive characteristic of fake news sharing is that many of the users of social media share every piece of news they see, regardless of the source of the news source. And this figure shows the results of the people with higher education, that people with higher education tend to check the source of the news they share on social media. And this table shows the results of the screenshots of the first 6 screenshots. These results show that even though most of the respondents think they know how to spot the fake news, they are not always successful. The first screenshots contained various information, various topics shown here. And this column, the first column, is the percentage of people who think it is a fake news, percentage of people who does not think it is a fake news, and if it is fake news, determined by different methods, several independent sources. From the table, it's visible that the post about the coronavirus statistic is causing the most confusion among the respondents, even though it does contain some truthful information. The way of its title is written makes the respondents question its credibility, and somehow the same results are obtained after the 2 definitions. The remaining 6 screenshots, the results are shown in this table. Again, 6 various topics and different percentage of people who think it is fake news and different percentage of people who does not think it is fake news. In conclusion, the ability to detect fake news and clickbaits in users of social media is evaluated and examined in our paper. A survey is done with more than 130 participants of various ages, education degrees, and professions. The most common source of news on social networks is pages that the users follow and shared posts from friends, and some of the users do not care at all about the sources of the posts they are reading and reposting. Most of the users does not share a piece of news if they think or are sure that it is fake. Regardless, there are users who does not care about the truthfulness of the news and are still willing to share it regardless. When asked to recognize the fake news among several screenshots, most of the respondents are managing to distinguish fake news from the truth. A little concerning is the fact that the only truthful screenshots in both six sections of screenshots are the ones that are the most wrongly classified by the respondents. This could be to several different factors and could be an area of further improvement in future research. And this is important to know the user's skill and ability to protect themselves in order to be able to develop some algorithms, machine learning algorithms, which will do this for them, this protection for them. Thank you for your attention. If you have any questions, I'm happy to answer.
Ms. Mladenova, thank you very much for your presentation. Dear participants, are there any questions about this paper? Okay, as I can see, there are no questions. We will go with the next paper. Paper number is 188. Are the authors of this paper here? 188. Okay, I guess they are not here, and we will go with the next paper. Paper number is 414. The title of the paper is Deep Learning Based Smart Infotainment System for Taxi Vehicles. I think Mr. Zoysa will present the paper, right?
Yes, I'm here. Thank you.
Okay, you can share your screen.
Yes.
Okay, we can see.
Can see my screen, right? The presentation is loading. Give me a second. Okay. All right.
Okay.
So
Yes,
I'm Sachin Zoysa from Sri Lanka, and our paper is based on deep learning based smart infotainment system. So an infotainment system is something you have in your vehicle, in your dashboard, which you use to play music and to do navigation kind of thing, and or maybe browse something kind of thing like that. That's we call as an infotainment system. And here what we came up with a smart infotainment system. It has kind of new 4 components, or we can say new features, like emotion-based music player, driver vocal behavior detection system, forgotten item detector, and driver distraction detector. I'll briefly explain these later on the slides. And under those 4 components, we'll be talking about the research problem and the methodology. So as I said, the typical infotainment systems, they do have only some kind of music players, browsers, navigation systems, video players, something like that. But in this project, we came up solving some issues which taxi passengers face. So we got an emotion-based music player, which will play music according to passengers' emotion, and a driver distraction detector, which will detect if driver is distracted. And also we got a driver vocal behavior detector, which will send reports about driver's vocal behavior to the taxi service providers, and also a forgotten item detector, which will help passengers to take their belongings back without forgetting them. So the main objective of this research project is to come up with a smart infotainment system for taxi vehicles to have well-disciplined drivers in taxi services, and to make a safe and comfortable journey for all the passengers at the end of the day. So this is the overall system diagram. You can see the smart infotainment system here, and there are 2 cameras mounted to the infotainment system, which is focusing on rear passengers and the driver. And also there is a microphone, which is helpful when considering driver vocal behavior detection. And the backend part of the service there in Cloud EC2 instance, and there we have 4 components for each 4 components, and we need an internet connection to the smart infotainment system to do the functionalities. So we'll start from the first component, the ImoPlay music player, emotion-based music player. So the problem was how to play music according to passengers' emotion in taxi vehicles. You know that if you get into a taxi, you don't have that option to play music according to your preference. Maybe you are in a happy mood, but the taxi driver may be listening to some sad songs. So that won't align with your mood. So we wanted to come up with a solution for that. So we came up with a deep learning based solution, and we need an emotion detector for it. We need a model. So we used a face expression recognition dataset by Jonathan Hicks, which was there in Kaggle website. And there are 7 classes as happy, sad, surprise, etc. So we use a convolutional neural network to build the model. And this is the system diagram for that particular component. We have the infotainment system in the client side. They will take the passengers' photos and send back to the server, which is there in the cloud, easy to instance. And there they will predict and give the output back. So within 1 minute, they will predict like 6 predictions. So also it has an accuracy around 78%. And you can see some predictions we did within this model. So next, moving to the next component, the driver vocal behavior detector. Here we wanted to focus how to monitor drivers' vocal behavior towards customer. There is no way to, there is no way to track the driver's vocal behavior by the taxi owners. They are in the office. So we came up with another approach for this, and we wanted to come up with a voice emotion detection model. So we used the Rauda speech emotion recognition dataset by Kaggle. And there also we got 8 emotion classes. And we use deep neural network to build up the model. And this is the system diagram for the voice emotion detector. So it's kind of same to the other component as well. The driver's voice will be recorded when he's talking, and then the voice clips will be going to the backend server and do the predictions. And according to the predictions, they will make kind of reports and send them to the taxi provider, service providers. And the accuracy of this model is like 60%. Then the third component, forgotten item detector. The research problem. So we focused on how to inform drivers regarding forgotten item in the taxi. Maybe someone can mistakenly forget the item in the taxi and get away from the taxi, but driver won't see that. Might be after several hours, the driver can see that. So then that must be too late. So we wanted a system to inform the driver at the moment the passengers left the vehicle by forgetting something. So we wanted an object detector to embed it into the infotainment system. So we use the Cocoa dataset because it has kind of 80 object classes, and we use that pre-trained model built by Darknet, the YOLO v3 model. In the literature, we saw that YOLO v3 by Darknet performs well in object detection. And the system diagram for this component is also kind of same to the other 2 components. Do the predictions in the backend and send it back to the infotainment system, which is in the taxi vehicle. So these are some testing we done using that model, and it has 60 mean average precisions, and it can do the prediction and send back the predicted result to the infotainment system within seconds, so that if something found in the seat, in the back seat, the driver will get alerted with the item that detected, so that driver can quickly ask the passenger who is outside the vehicle to take the belonging back. The last component of this smart infotainment system is the driver distraction detector. So how to identify the distracted driver in a taxi vehicle. So that's something related to the safety of the taxi ride. And there we need the model to track the drivers, whether the driver is distracted or not. We got the State Farm dataset from Kaggle, which has 10 classes, and we use convolutional neural network to train the model. And this is the system diagram. They will take pictures of the driver and send it back to the server and getting the prediction. So if the driver is distracted, the system will again alert. So the passengers or the driver can hear that alert, and they got to know that the driver is distracted, so they can focus on their drive. So these are the results and discussions. So the accuracy of this model is around 90%, and you can see some examples as well. So when it comes to the conclusion, this infotainment system, this smart infotainment system, which is built by us, have 4 new key features, starting from the forgotten item detector, the IMOPlay music player, driver distraction detector, and driver vocal behavior detector, which will help passengers and also taxi service providers to have a safe and comfortable journey. And also, if taxi purchase this kind of product, they can commercialize this item to have more, to engage more customers, that we are having these kind of features. You can listen to music what you want, what you feel, what music according to your emotion at the right time. So just ride with us. And we have these driver distraction detectors, and also they can commercialize their taxi services by using this product. So that's it with the presentation and the research presentation. Open for questions. Thank you.
Thank you very much for your presentation. Do you have any questions about this paper? Okay, there are no questions. Thank you very much. We will go on with the next paper. Paper number is 73. The title of the paper is Freshness Classification of Hot Plan Fruit Using Deep Learning. I guess
Yeah, I'm the speaker. I'm here.
Aruna Juhaleswaran will present. If you are ready, you can start.
Yeah, sure.
Okay, you have 10 minutes to present your paper.
Sure. Is my screen visible?
Yes, we can see your screen.
Okay. Yeah. So I'm from University of Petroleum Engineering Studies. Our paper is titled Freshness Classification of hog plum fruit using deep learning. Hog plum is a very common fruit in India. It is like turned into jam, pickles, and things like that. It is also consumed directly and things like this. It is commonly present in other Asian countries as well. So fruit classification can be of hog plum can be done by analyzing the shape, color, and texture of the fruit. If some things are universal standards are defined, then machines can do it automatically. This will be having a big impact in the food industry and things like that. Hog plum is also used for like regional medicine, folk medicine, and purposes like that as well. As far as we know, there is no existing work in this area. The classification of hog plum is very, very unexplored. So this is like one of the first papers in this area. So yeah, this is our methodology. Initially, like we collect hog plum fruit samples from Agri Horticultural Society, Kolkata, and then we capture it into the images. And we have a panel of experts to determine its quality. And they assign it hedonic values for each of the attributes like color, texture, and shape. Based on that, based on those images and classes, we perform augmentation training and followed by grid search, hyperparameter optimization, and we basically evaluate the results of the model. So let's get this into detail. As I mentioned before, we did perform sample collection. The hog plum samples were like around 100 to 120 days. They were collected from Agri Horticultural Society, and we took multiple images of each hog plum from various angles as well. So in total, there were around 275 samples. We did a 70-30 split. So like 70% of it was used for training, and like testing, 83 samples were used for testing purposes. So firstly, we also determined the quality class from the hedonic by the panel, and from that I'll give it a freshness class, like whether it is fresh or not. This is done based on the hedonic values. So this is how an hog plum looks like. This is an example of a fresh hog plum, and this is an example of a non-fresh hog plum. In this case, the differences are very much exaggerated, but in practice, these two are a little bit hard to distinguish for the untrained eye. So for the quality classification, basically, like if any one of the hedonic values is less than 5, the hedonic values are in the scale of 1 to 9. If any one of them is less than 9, we say it is a non-fresh one. Otherwise, we say it as a fresh one. So this is basically how we assign a class assignment based on the quality, the hedonic values given by the panel of experts. So yeah, so like coming to pre-processing and augmentation. Initially, we resize the image into 224 by 224 H3, and then we apply normalization. This normalization is required for auto augmentation. We are using the augmentation policy which was learned on ImageNet dataset. Like we are using automatic augmentation over some kind of manual strategy, as these are like produce better results, and they have also produced the state of the results in the past for standard data sets like ImageNet, CFAR 100, and things like that. So in we are primarily using these 4 neural networks: ResNet 18, MobileNet version 2, MobileNet version 3 small, and MobileNet version 3 large. We are using these because these are all low power models and small models as well. This would mean that they can be used on mobile devices, embedded devices, in that context as well. That is also one of the goals of our paper. So coming to the how we are training it, as I mentioned before, we perform the pre-processing, which is basically involves resizing and normalization. Then we use automatic augmentation, and as our dataset is quite small, we are using transfer learning based on the pre-trained models of these architectures. Right, and the pre-training was done on the ImageNet dataset. We are using Adam Optimizer, and hyperparameter optimization is performed using grid search. And the only hyperparameter we are optimizing is batch size, because we have experimented with other hyperparameters, and they don't seem to be making too much difference as compared to batch size. And like we are performing threefold co-cross validation, and we are also having early stopping. We are training for 20 epochs, but because early stopping is there is like a patience of 5 epochs, and most of the training has converged before 15 epochs. So let's come into the results. Like all the training and things like that were performed on Google Colab on a K80 GPU, and like we tested 83 samples, as I stated before. And we see that ResNet 18 made the fewest classification errors, and MobileNet version 3 made the most. Although the ResNet 18, MobileNet version 2, and MobileNet 3 are very close, ResNet 18 makes more type 1 errors than type 2, and MobileNet version 3 makes model makes no type 2 errors. And we see that ResNet achieves overall the best one. It is closely followed by MobileNet version 2 and version 3. And we also see that MobileNet version 3 large is worse than MobileNet version 3 small. This is because it is not able to generalize that well MobileNet version 3 large when compared to MobileNet version 3 small on a small data set. This is one of the issues with MobileNet version 3 large, at least in our case. Yeah, and we will see how they performed in Everything metrics. And yeah, first we'll come to the training scores. So this is the ResNet 18's training scores. This is during the threefold cross validation. As we are performing grid search, we are exploring 4 different batch sizes: 1, 8, 32, and 64. And these are all the validation scores, that is accuracy score for each split. So we can see that like 1, it is like very bad. 8 is performing the overall best. 32 and 64 are performing pretty well, but not as good as 8. We also tried other manual training and things like that outside of this threefold cross validation. In those stages, sometimes we were able to get like better accuracy than this, like 99% and things like that. However, those models were not stable. Like when we augmented the test data a bit and tested again, the accuracy drops off dramatically. But when we do this kind of process using grid search and cross validation scores, the models are very stable. When I say 98% accuracy, even if the test data gets augmented and tested again, in those cases as well, this performs very well. This is one of the main justifications for using this grid search and hyperparameter optimization. Now coming to the same thing for MobileNet version 2, we can see that again, once again, batch size of 1 is performing very badly. 8 and 64 are decent, but in this case, 32 is the absolute best. And once again, for MobileNet version 3 small, we could see similar results, but in this case, we can see that 8 is performing, 8 and 64 are not performing as good as 32, and the performance of batch size of 1 is also close to 8 and 64, somewhat compared to that. And coming to MobileNet version 3, you can see that 8 is performing, having a stable 94% training accuracy. But however, 1, 32, and 64 are all having around 75 to 80% accuracy. And they are not as good. This is because, as I stated before, MobileNet version 3 large isn't capable of generalizing as well as the other models in that case. And now coming to the testing metrics, we have tested various metrics like accuracy, area under the curve, recall precision, F1 score, and balanced accuracy score. We can see that clearly ResNet 18 is much better in terms of every metric except precision. The reason why it isn't that good in terms of precision is that it makes less false positive errors. That is, it makes more type 2 errors than type 1 errors. These MobileNet based models tend to classify things with a lot of green, Hawkplum with a lot of green patches as fresh. Whereas ResNet doesn't do this as much, and it actually considers shape and texture as well a little bit more. Now coming to the ROC curves, we get nearly ideal ROC curves, as we can see, and nearly a perfect AUC score as well for almost all the models. You can also see clearly that MobileNet version 3 isn't as good as when compared to ResNet 18 or MobileNet version 2 in this case. Now we can also show the confusion matrix.
Sorry, I have to remind you that your 10 minutes duration is over. Please summarize your paper.
Yeah. I'll just summarize. Yes. Yeah, as we can see, this is the confusion matrix. As I stated before, ResNet 18 makes more type 2 errors than type 1, and other things make more type 1 than type 2. So this is basically the thing. So coming to the conclusion, we have developed a system that can classify the freshness of Hawkplum fruit, and we see that ResNet 18 is the best with an accuracy of 96%. The small nature and collection of samples from one place limits our analysis. So we could take samples from multiple places and analyze. This would make the analysis more robust, and we can see this. And the same technique can be applied to other things like fish, Goa, and etc. And also, like a mobile application or a web application can be developed so that it can be used for in a wider purpose and in some practical context as well. These are all left for the future. Thank you. Any questions?
Okay. Thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, I guess there are no questions. Thank you very much. And we will go on with the next paper. The paper number is 298. The title is Patient Gender Identity Information in COVID-19 Severity Detection on 3D Chest CT Scans via Deep Learning. I guess Falana William will present, right?
Hello,
Can you
everyone.
hear me?
Yes, I can hear you, sir. Good evening, sir.
Okay. You can start your presentation.
Okay, sir. Hello, everyone. Today, I'll be talking on the paper titled Patient Gender Identity Information in COVID-19 Severity Detection on 3D Chest CT Scan via Deep Learning. So firstly, we're going to be discussing about the goal, just brief information about COVID-19 and medical imaging, deep learning, and then we'll move to the methods that we adopted. And then we're going to see the data set that we used, some brief information about the data set. We're going to elaborate on what we did and the performance of the work we did and evaluation from our yardsticks. And then we're going to come to the conclusion. So firstly, the goal of the work is to investigate how deep learning will be able to differentiate COVID-19 severity in male and female images, especially because now, deep learning classification requires some sort of input, and our input here is CT images. And then we're going to quickly look at brief information about COVID-19. Firstly, it's a global infectious disease and has caused widespread of deaths. And we see that it's a disease that attacks the lungs area. And we see that people who are infected exhibit some few symptoms like fever and flu and some sort of nasal congestion. And we also noticed from over time that COVID-19 could be just mild, which means it may not be severe in patients, and also it can be severe. And when it's severe, it requires special medical attention. So this research is to help the radiographers in the hospital to be able to detect immediately which COVID-19 is severe and non-severe, and also to assist them in detection of this kind of severity in both male and female gender. Now we are going to look at medical imaging. There have been several technologies that have been brought into the limelight that has helped improve medical imaging, and we know that these things cannot be done without medical imaging. So an example of such technology is computed tomography, CT scans, and they are available in most medical centers across the world, and they have the ability of scanning human body and detecting some physical changes in some region and part of the body, internal organs of the body. So they have the ability to reveal that. And we also know deep learning is subfield in machine learning, and ResNet 50 is another part of deep learning algorithm that was discovered, that came to limelight in 2015, and has really been used in several experiments and investigations, and that's really been so successful. And it was, according to several researches and papers, it was said that it could predict clinical outcomes and could perform medical classification efficiently. So the method we use, we are just going to just go a little bit deep into it. So, the data set we used was a 3D CT scans, and from the STOTIC 2021 data set that's available online. So we had to convert these 3D CT scans to JPEG images. So how did we do that? So we adopted this first method using image slicing. So we sliced the image using a software called 3D Slicer. So this software helped us to slice images into 3Ds, and which include the upper and the lower and the middle long slices. So after slicing these images, we further process the images using image resizing. And how did we resize the images? We resized the images to a length that was able to fit into the input of the ResNet 50, and that was 227 by 227 by 3. And also we did some data augmentation to enlarge our data set, and then from the data augmentation, we were able to we did it by rotating most of those images at different angles to be able to enlarge our data set. And also we did the classification using ResNet 50. So as you have seen, before the augmentation, we had we're able to sort out the data set, and for male non-severe cases, we have 117 images that was available to us, and for male severe cases, we have another 117 cases also that was available to us, and which we tested 50-50. So in total, we tested 100 of them for the male and also female, and also then the third scenario was we tried not to consider the gender. So we mixed both male and female together to see how well they perform. So that's all about that. So how did we go about this? Firstly, we took the first scenario, which was to distinguish between male patients, severe and non-severe. So we used 234 CT images for that, and then we tested 100 CT images. And after that, we were able to achieve an AUC value of 0.98, which is close to 1, which looks like a perfect system, and also an accuracy of 0.96, which is close to 1 as well. For the female also, we were able to distinguish between female severe and non-severe also. We had an AUC value of 0.98, which is close to 1, and which means that the system was a perfect classifier, and also the accuracy was 0.95, which is also close to 1 and reasonably okay. But when we didn't consider the patient gender information, which means that we mixed both of them up, we discovered that there was a decline in the AUC value, which declined from 0.98, as you see in the previous two classifications, to 0.93. And also we see that the accuracy also declined to 0.85. So which is giving us some clear indications for our conclusion. So from the confusion matrix, you can clearly see that the true positives and the true negative, the false positive, the true positive was 96 in this case, and the false positive was just 4. False negative was 4, and then the true negative was 96. And similar, this for the male severe versus non-severe, and also it was similar to the female severe versus non-severe case. But when we come to the one in which we didn't consider the gender, mixture of the genders, we discovered that there was more false positive and more false negatives. Also, we can see from the row curve as well that for the male severe versus the non-severe, we see that there was the row curve was a bit okay, which was able to give us a very good area under the curve at 0.98, as you see for both male and female. But when we didn't consider the gender information, we discovered that the area under the curve for this row curve, male and female mixed together, dropped. So clearly, what we're able to do, what our deductions from this experiment that we carried out, firstly, we're able to see that a deep learning architecture like ResNet-50 was able to differentiate between COVID-19 male severe cases and non-severe cases, and both in female severe cases and non-severe cases, and also was able to distinguish between when the patient's severity is not included and gender, when the gender was not included, it was still able to distinguish between severe and non-severe as well. But we were able to measure this, we were able to measure our experiments with the accuracy, sensitivity, specificity, and AUC. And our finding, we could see that ResNet-50 could differentiate between COVID-19 severity in male and female with high accuracy. And also we noticed that when the gender information is not taken into account, there was a decline in the accuracy, which we believe is as a result of maybe the different body grids of both male and female may be a factor that has affected it, because the male and the female may the diameter of the CT scans may vary, which may cause some itch in the testing process, and maybe part of the cause of the failure to properly distinguish when they are information, their gender information was not included. And also, we also believe that the result worsened as COVID-19 affect male and female patients differently. So the damage that COVID-19 may do to the lungs region in a male may be different from the female. So those are our assumptions that we deducted from this. So we're trying to say that when we are trying to distinguish between severity in both cases, we should make sure that we consider the gender, for us to be able to get an accurate result. Thank you very much.
Thank you for your presentation. Dear participants, do you have any questions about this paper? Okay, there aren't any questions, and we will go on with the next paper. Paper number is 421. The title of the paper is Machine Learning Algorithms in Big Data Analysis and its Applications, a Review. I think Shahab Karam will present.
Yes.
If you are
yes.
ready,
Yeah.
if you are ready, you can share your screen.
Okay. Thank you.
You're welcome.
Did you see the screen now?
Yes, we can see your screen. You can
Okay.
start.
Okay. Hi, everybody. My research paper is about the machine learning algorithms in big data analysis and its application as a review. As you know, we have now big data is one of the revolutions of the data and how can we store the much amount of data and how they generate the data by the companies. As you know, for everybody, Facebook, they have generated for more than 7 terabyte per days, and the YouTube also they generate more than 3 terabyte per day. So this is make the data to be a huge amount of data, and the researchers are now working on how can be analyzing or making a decision about this data. If you have the huge amount of data, how can be implemented? So the big data is one of the challenges, and how can apply the analyzing of the data, because all the times in the big data, we have several types of the data. Some of these is unstructured data and structured data and semi-structured data. So they combine all these data and can be generated by the users. So the companies or the researchers needed to be collect all these data and implement it. So the one of the challenges is storing or searching and sharing or transfer or analyzing. Actually, the visualization is also the problems for the big data. The 5 V in big data, as you know, you have volume, velocity, variety, veracities, and values. So also we have the now it will call 9V, because also every times they can be increased the number of V. For example, the visualization is also one of the issues that can be implemented. How can we visualize a big data? So the challenges for this big, the volume, amount of data that we have it, and the velocity, the speed of the data that we need to receive it or the analysis, or the variety, how much types of data we have. Can you collect the data from several server or several different types of the operating system? And the veracity is also the quality of the data. We also the analysis about the value for the prediction or forecasting the marketings. So the characteristic is also we can be implement in the several values. For example, the V and the volume, value, veracity, and variety. All these is the challenges and the big data. One of the challenges of the big data to solve each part. So each applications or each algorithms, they try to implement or resolve or finding some solution for these V. In this lecture, we talked about some of the machine learning's algorithms that will be implemented inside big data. Actually, we are working on Hadoop several times, and we found that we have some of the algorithms worked on the Hadoops as the for solving for some of the challenges, for the values, or the velocity, and so on. So we found some of the algorithms can be implemented in the machine as a machine learning algorithm in the big data. So the machine learning is also, we have several algorithms cannot be implemented. Till now, some of this algorithm is not be implemented or cannot be implemented because we have also some challenges because the types of the data or the variety of the data source as well as the speed. How can we implement this part? So the machine learning can be categorized in the 4 types: supervised learning, unsupervised learning, semi-supervised, and the reinforcement learning. Till this time, I think so. All the papers that will be implemented focused on the supervised learning and the unsupervised learning, but the semi-supervised and the reinforcement learning, actually I don't found it some of the papers. Maybe we can find it in some of the journals, some draft or a small paper, blue paper saying about the reinforcement learning in the big data, but they focus now on the supervised learning because all the times, and as well as the unsupervised learning, because we have a huge amount of data. Hadoop is one of the informations about how can we implement the big data as the clustering. Is one open source from Apache. They have some properties. It's called also the Hadoop distributed file system. As you see in the figures here, we have the layers of the figure, and one of the implementation is the machine learning is called Mahout. Mahout is one of the open source. It will be work in the Hadoop that will be implemented some of the machine learning algorithms in Hadoop. As you know, the Hadoop offers some scalability of the analyzing the data easily. For examples, scalable to petabytes more easily as the volume, and offering the parallel data processing as the velocity, as well as storing all kinds of data variety. So the Hadoops offer 3 challenges in the big data, which is volume, velocity, and the variety. So inside Hadoop, this is the architecture of the Hadoop. One of the success of the Hadoop is to avoiding the fault tolerance. So because all the nodes we can see they make sometimes of the fault to some techniques that can use to avoiding the fault tolerance by replication each times for any parts of the data. It will be replicated in the 3 by the default they are replicated in the 3 nodes, so that each node can be stored the same data. For example, the data node here that is colored by red, it can be replicated in the other nodes as well as in the other node in the other rank also. So this is make to avoiding any fault tolerance of the big data in Hadoop. Inside Hadoop, we have Apache Mahout. Mahout is also the open source. It will be implementing a machine learning library from Apache. It's scalable, but we have one of the problems here. It will be implemented as the Java library. It will be make some implementation because the Hadoop also is open source implemented by Java. So this is make some restriction because some of the algorithms maybe we needed to implement it by the several types or several languages. But Apache Mahout is only supported the Java programming. We have the other things is the Spark. Apache Spark is also the open source from the cluster computing frameworks. One of the advantages of the Apache Spark is the real-time processing. because the Hadoop or Mahout, they haven't these properties for working in the real-time processing, but Apache Spark working on the real-time processing. The Spark also provide some interface for the clusterings and also implement in the Hadoop MapReduce that can be implement any parts of the algorithms. For all the algorithms that will be implemented in the Hadoop, they use the technique of the MapReduce as we mentioned. The Spark ecosystem, they support different languages, Scala, Java, Python, and R languages. So this is one of the flexibility of the Spark. They can be not implemented only in the Java programming. They have the Python and the Scala and the R languages. In this paper, we collect several paper, and this paper, some of them will be implemented in the Spark, and some of them it will be implemented in the Spark and the Mahout. But by the result, if we presented in the papers, we see that all the papers that will be implemented by the Spark, they have more efficiency and the speeding also more, as well as they can be implement the several more algorithms than the Mahout. All this algorithm will be implemented in the Spark, as well as we have the other algorithms, for example, K-means and the K-means canopies implemented in the Mahout, but these also will be implemented as the languages Java programming. We also, in the Mahout, we have the naive Bayesian and the naive Bayesian and logistic regression also implemented, but they used MapReduce programming, not only as the machine learning algorithms that we have, because the MapReduce also we have the several techniques or the technique it will be flexible. We have the key and value, and we can be implemented. One of these algorithms called word counting. It will be implemented. How can we implement the word if you have the several gigabytes or terabytes? How can we implement for word counting, finding the number of the word that will be repeated in these documents? So the conclusion for this paper, as you see, we have the several companies. On this company, it will be implemented. It will be decided which algorithm it will be, which technique that we use it, the Spark or the Mahout, based on the types of the data and the flexibility of the data and the varieties of the data. So the aim of this paper to be collect all the algorithms that will be implemented in the big data as applied machine learning algorithm for the big data. Additionally, we have the most application supporting for the financing and the healthcare. It will be used also because we have also the training and testing. So this is also make the challenges for the big data. How much of data that can be analyzed? If I use the clustering, how can be implemented? Or if I use the big data as the Mahout or the Spark, which will be better than cluster. This is our presentation. If you have any questions, we are ready. Thank you for listening.
Thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, as I can see, there are no questions. Thank you very much. We will go on with the next paper. Paper number is 66. The title of the paper is Anomaly Detection of Web Traffic Between IoT Devices.
Yes.
I think.
Yes, I'm ready to present. Sir.
Okay. Ali Mohammed Faris Al Samiri will present.
Yes.
Am I right?
Yes.
Okay. You can start your presentation.
Okay, welcome all. I will present anomaly detection of web traffic between IoT devices. My name is Ali Mohammed Faris. The introduction. Over the last decade, the global has seen an increase in the number of illustrated Internet of Things devices, IoT, connect all the type of intelligent devices over the internet. This establishing a great integration that allows multiple apps to operate in both the actual and virtual world. These applications can range from a basic smart home product to a sophisticated equipment for manufacturers plan or critical infrastructure. The eyes and the ears of the Internet of Things (IoT) are the devices, sensors, those nodes, and sometimes unanomalous behaviors appears, causes network interruptions, which can be triggered by a cyber strike or sensor modification. This may have a negative impact on the industry, whether on a private or a public level. For example, if we have a bank payment service or a factory line, it will, if there is any a problem, we must to know and find the issue. So as a result, detecting anomalies is critical. Machine learning algorithms have risen a significant possibility in medical, industrial, and other fields for detection anomalies and monitoring data from IoT network devices. The protocol has been used. HTTP hypertext transfer protocol is the most widely used protocol to transport data traffic from for monitoring and analysis purposes. So what we propose, a compression between a specific model which support heterogeneous devices and detect the anomalous data. Three different machine learning algorithm has been used: K-nearest neighbors, random forest, and XGBoosting classifier are applied for solving issues related to data traffic management and network monitoring, showing that even with the poor data traffic, accuracy between 80 and 90% is achieved for efficiently detecting anomaly in IoT network. Methodology. We propose a model that detects the anomalous data traffic via HTTP protocol by using identity of the devices, sensors that are connecting to the network. At the same time, we utilized three commonly used machine learning algorithms to detect anomalies in actual time and with a high accuracy by using the same data. The data sets applying, we use a data set from Kaggle data sets, which is called IoT devices identification. This data set consists of 2 files, and for each file has 200 and more than 250 columns of data. This freely associable data was created particularly to simulate an IoT environment. This data has the data of 10 different devices sensors such as TV, baby monitor, light, water sensor, etc. Each column represents a device from the experiment setup and present the amount of the data traffic produced by them. Here we can see each sensor and how many packets have each sensor, and the water sensor have actually 100 packets. Proposing the data set. Both training data and testing data has same number of columns in the data file. We have to predict the device category, but unfortunately the column devices category is also in the test data too. There are two approaches to handle this problem. If the target column of the both training and testing data file have different number of unique values, then we have to drop the extra categories or unique values to balance the data. But by doing this, so we may lose available information about the particular category if we drop it. The second one, we can combine the two data file, and then by retesting and retraining, we can tackle the problem. To succeed, we will preparing the data, we will combine the data file together, and the result of maxing of the data category column, then we split the data to retest and retrain. Experimental setup and result. The experiment is on Kaggle website. There are no requirements for the operating system. We use Python programming language in our experiment. In order to test the data set, we use 3 algorithms, as I said previously, and which is we test each algorithm individually, and after that we use a cross-validation function for testing the algorithm all together to evaluate across the score of all methods. The cross-validation splitting strategy is 5 CV. For the KNN, the number of the neighbors is 2, and for the random forest classifier, the maximum depth was 8. The total number of the packets 1,900. In order to test and train the model, we used 1-to-3 ratio for splitting the data. The evaluation, we assess the performance of our model using the confusion matrix and other matrices such as accuracy, recall, F1 score, maximum iterations. Accuracy is the difference is defined as the number of correct products, both positive and negative products, divided by the total number of the estimated products, and based on the equation where FP is a false positive and FN false negative, and TP is a true positive and TN is true negative, and as shown in the equation. The result was for the KNN is as shown for each sensor, the precision and recall and F score and the support, and the accuracy was 85%, and for the random forest was the highest one, 89%, and for the XG boosting classifier was 88%. And after that, when we applied the cross-val score function, the result was the validation splitting strategy, and it's applied at all model to see the evaluation. The F1 score was for the KNN is 76, and random forest was 86, and the XG boosting classifier was 87. For the CV was 5 for splitting, and as shown as in the picture below. Conclusion. The status of for each device's sensors that connect to the IoT network and present the result for each algorithm, and the cross-validation strategy to improve the detection of anomaly behaviors of those devices sensors to prevent any risk that can cause serious harm. not only on private level, but also on a global level. We monitor the data pattern in general. We calculate the F-score for the k-nearest number approaching to 85, and for the random forest approaching to 89, which is the highest result, and the XG boosting classifier approaches to 88. Our primarily experiment show great promise. In the future, we will focus on building an IoT framework that provides real-time detection for anomalous behavior of those equipment. Thank you all. Any questions?
Thank you very much for your presentation. Are there any questions about this
Okay.
paper? As I can see, there are no questions. Thank you very much again. And
Thank
we will
you
go
very
with
much.
the next paper. Paper number is 237, and the title of the paper is Google NetCNN Classifications for Diabetics Retinopathy. The author of this paper is Ayman Mohammed. If you are ready,
Yes,
you
I'm
can
ready.
you can share your screen and start your presentation.
Okay. Thanks for release microphone to me. My name is Ayman Hassan Mohammed. Ladies and gentlemen, hello everyone. Paper title, GoogleNet Convolutional Neural Network Classifications for Diabetic Retinopathy. And slide outline, it is contained on introduction, background, methodology, results, discussion, and conclusion. In slide agenda, here, what is diabetic retinopathy? How machine learning served in diabetic retinopathy classification? How we worked on enhancement of the system? How the proposed system behave with the dataset? What does the results mean? And conclusion. In introduction, academics and professionals are increasingly using image processing. Medical image helps manage, segment, analyze, transfer, and diagnose medical images. Digitized images help in computations, imaging, and illness detection. Recent breakthroughs in this discipline have improved patient treatment. Diabetic retinopathy is a major problem. It's a retinal complication of diabetes. Physicians are reaching deeper into the body to diagnose illness, track changes, and find better remedies. Diabetes causes diabetic retinopathy, debilitating eye disease. Obscure retinopathy causes blindness and blood vessel problem. Retinopathy causes abnormal blood vessel to develop and proliferate on the outer retina, causing exudates to accumulate in the retina's multi-layer back lobe. Diabetes testing is progressed. When defective blood arteries leak or delayed fat lamps exude, fovea haste visual acuity is the retina's median. because I have a specific time, I will pass some slide. Here in introduction, we have two images of retina human. This image contain on other type of illness of diabetic retinopathy. This illness may be hemorrhages, exudates, microaneurysms, and blood vessels. These types of illnesses may be caused blindness in human. Background: how machine learning served in diabetic retinopathy classification. Early identification is key to stopping the disease progression and helping the blind. Every 6 months, a procedure is needed to monitor the illnesses. An algorithm that finds and identifies Funt's image will reduce DR, diabetic retinopathy, related blindness. Researchers developed image analysis tools to identify retinopathy. Image processing has evolved. So using AI particular equipment or algorithms, grayscale or color image can indicate normal and defective retina. Here we can show some literature review about the illness. So naive Bayes-based expert system diagnoses disorders using the natural grid that estimated the lighting. So he used algorithms called SVMs, support vector machines, employed these photo properties to diagnose and determine diabetic retinopathy. Methodology: how we worked on enhancement of the system. Pre-processing, segmentation, and classification are three important technical methods that make use of the photographs in this study. Medical imaging relies heavily on this on the use of computer to identify disease, finding radical solutions to problems and obstacles related with retinopathy, such as the accuracy in recognizing signs and forms of illness, and the appropriate method of diagnosis was the goal of this study. Here, this chart of algorithm, this line for color image and this line for gray image. This for pre-processing and this for feature extraction, and then at the end, diagnosis by CNN. It began input retina image and then correcting image flows, and then resized retina image, and then to gray image, applying some filtering on image, such as apply Gaussian filter, apply median filter, and then compute color feature from color moments. These two, as we say, two color image convert to gray level and then apply algorithm of Kali, and then apply GLCM algorithm, and then to extract feature, and then to classification by CNN into normal or abnormal of image. GoogleNet CNN architecture. Google researcher, with the help of several universities, launched GoogleNet in their 2014 research article, going deeper with convolution or inception v1. This design won the 2014 ILSVRC photo classification competition. It has lower error rate than previous champions, AlexNet and ZFNet, as well as VGG 2014 runner-up.
Mr. Mohammed,
Yeah.
Your 10 minutes duration is about the over. Please try to summarize your paper.
Oh, okay, no problem. So we use the MATLAB is the program language of choice for our methodology and code output. The GoogleNet CNN architecture was employed in this project. We will go to the important part in this presentation. It is results. We have three training options. The first one, stochastic gradient descent with momentum. The training results are shown in detail. The validation accuracy is 96% in a time elapse equal to 6 minutes and 47 seconds. The training and validation loss metric was overfitting. The second training option is ADAM optimizer. The validation accuracy is 96% in a time elapse equal to 3 minutes and 5 seconds. The training and validation loss was slightly overfitting. The third training option was RMSP ROP optimizer. The training results are shown in detail here. The validation accuracy is 92% in a time elapse equal to 3 minutes and 11 seconds. The training and validation loss was good fit. In discussion, a summary of all results is presented in a table regarding time and accuracy. ADAM option was the best one. RMSP-ROP shows the best ability for fitting. The purpose of this is to diagnose the model's performance and identify which aspects need tuning. RMSP-ROP option make the GoogleNet CNN implementation the best model in this application. ADAM option GoogleNet CNN implementation perform the best accuracy in the optimum time. In conclusions, in this study, an implementation of CNN architecture in GoogleNet interception was proposed for retinopathy diabetic detection. Figures of retina was classified using 144 layers of GoogleNet CNN method and trained using multiple training options. The comparison shows that ADAM's option for GoogleNet CNN is the optimal option for retinopathy diabetic disease detection. Thanks for listening.
Thank you very much for your presentation. Are there any questions about this paper? Okay, There are no questions. We will go with the next paper. The paper number is 111. The title of the paper is Laminate Entanglement in Quantum Information Processing Utilizing Hybrid Quantum Classical Neural Networks. And the author is Ather Hadi.
Yes, sir. I'm ready to present my paper. Thank you very much. I
Okay.
guess I have less than 10 minutes. That's right?
You have 10 minutes. Not less than. You have 10 minutes. No
Thank
problem.
you very much. Thank you very much.
You can share your screen now.
Yes. Ladies and gentlemen, on behalf of my university, Altinbash University, where I belong to.
Sorry,
as
we can't see your screen.
you can see my screen.
No, we cannot see.
You cannot see my screen. Let's share screen. Share now.
Yes, we can see now.
Okay. Okay, ladies and gentlemen, on behalf of my university, Altinbash University, where I belong as a student, you are welcome in this scientific congress. At the beginning, I would be pleased to introduce myself. My name is Ather Salah Hadi Al-Isawi. I'm a high school teacher in Iraq, and currently I'm a graduate student at Altinbash University. Let's commence to clarify briefly the topic. Eliminate entanglement and quantum information processing utilizing hybrid quantum classical neural network. In this modest research, the researcher attempts to explain and simplify the understanding of the one of the quantum information processing problems represented by the quantum entanglement, and to clarify how to take it over. In fact, understanding quantum algorithms demand to understanding some terms in advance. For instance, a particle generated inside a group cannot be described independently of the other group particles during the interaction or sharing, or the development of a particles group includes geographic in a quantum mechanics. Particles arrangement represent their quantum state at zero temperature and highlight the particles' energy and symmetry gap during the symmetry protected topology, and provide a more consistent method for differentiating the quantum data sources features, such as quantum sensors or complex simulation of device through quantum entanglement. And this is what the TensorFlow environment provided with Python programming language, which supported by Google. In fact, there are two types of algorithms. The first type depend on linear algebra equations, such as, for instance, the classical algorithms, as well as the first generation of quantum algorithm. And the second type depend on nonlinear algebra equations. For instance, the second generation of quantum algorithm. The first type can be implemented on classical device, and the second type can be implemented on quantum device. And the second type, exactly what we are talking about. Anyhow, basically it demands to convert classical data into quantum data firstly. Consequence, it yields basic model which need to train. For one qubit, the Bloch sphere can be depict two categories. States in category A are blue, while states in category B are orange. The vector are the states around which the samples were taken. For classification over this on this one qubit, we notice that we have 5 steps. Step 1, quantum data to be classified. Step 2, parameterized rotation gates, whose job is to remove superposition in the quantum data. Step 3, measurements along the z-axis of the Bloch sphere, convert the quantum data into classical data. Step 4, classical post-processing is a 2 output softmax layers, which output probabilities for the data to come from category A or category B. Step 5, categorical cross entropy is computed between the predictions and the labels. Indeed, if we concentrate on the TensorFlow quantum pipeline, we notice it consists of the same 5 steps we talking about. The first step, it's a quantum data set preparing to be a classification. The second step, quantum model evaluation, and the third step is sample or average to measurement the z-axis of the Bloch sphere. The fourth step, what we concentrate about it, because it causes to eliminate quantum entanglement. This step called a classical model evaluation. The rest step, cost function evaluation, to determine where the operation go on. If this contain as a value for 100% accuracy, we can get the final data step. Otherwise, we can evaluate the data through either a quantum data evaluation or classical model evaluation. Actually, the researcher trained 3 types of models. The first type, called a pure quantum convolutional neural network, and yet validation accuracy didn't exceed 90% within 10 epochs. The second model, called hybrid quantum classical convolutional neural network, with a single filter, applying 1 layer of a quantum convolutional, reading out z-axis on Bloch sphere on all bits, followed by the densely connected neural network. With very modest classical assistance, the hybrid model will usually converge faster than the purely quantum version. And the validation accuracy rises to 100% at 3rd epochs. The third model, called hybrid quantum classical convolutional neural network with multiple quantum filter, an architecture that uses multiple quantum convolutional and classical neural network, can combine them, and the result could be validation accuracy rise to 100% at the 7th epoch. As a conclusion, the accuracy was determined in a purely models results didn't exceed 90% accuracy within 10 epochs, whereas the hybrid models results were accurate to 100% at 3rd epochs with a single filter, and at 7th epoch with a multi-filter model, with the goal of eliminate quantum entanglement. This our reference, and as acknowledgement at the first, I would please to appreciate all participants in this scientific congress, as well as I admit to Professor Dr. Mesut Çevik and Professor Dr. Asad Sabah Hadi for their guidance and encouragement during prepare this research. That was all. Thank you for your attention.
Thank you very much for your presentation. Dear participants, do you have any questions about this paper? Okay, as I can see, there are no questions. We have just one more unpresented paper. The paper number is 188. Are the authors of this paper here? Okay, I guess they are not here. Dear participants, we would like to thank you for attending the Congress, and we hope to meet you in next conferences. And now I'm going to end the session. Thank you very much.
Thank you very much, sir.
Thank you very much.
Thank you so much.
Have a nice day.